Question: if you reduce the universe, and the Earth will become the size of a small grain of sand, how big will the observable universe be? The size of an orange, or maybe with watermelon, or even a basketball. In fact, it would be bigger than the Sun. And not a bit bigger, but 30 times bigger. It's very hard to realize, but don't switch. I've shrunk everything in space so that we can finally really understand how huge the universe really is. The diameter of the Earth is 13,000 kilometers, and for us, it is a lot. It will take a commercial aircraft approximately 45 hours to fly around its circumference. But on a universal scale, the Earth is a tiny speck of dust compared to other objects in the solar system. Take Jupiter. It's the largest planet in our system, and it's a gas giant 11 times the size of Earth. Its diameter is 141,000 kilometers, but nothing compares to the Sun with a diameter of 1,400,000 kilometers. It would fit more than 1 million copies of the Earth. These are huge numbers, and you must admit, it is difficult to realize how it all looks. To understand the scale of the universe, let's reduce it and use something familiar: food. Let's start with the smallest planet of the system, Mercury. On this scale, it would be like a pea of pepper. Earth and Venus are slightly bigger, so they would be the size of cherry tomatoes. At the same time, Mars would become something like blueberries. Saturn is the size of a grapefruit, Uranus is the size of an apple, and Neptune is like a lime. Then Jupiter will be the size of a watermelon. But if Jupiter is a watermelon, then what kind of fruit or vegetable can the Sun be? Perhaps one of the largest jackfruit or pumpkin. Or even zucchini. A good version, but unsuitable. Since the Sun is 1,000 times larger than Jupiter, its size would be closer to a large skyscraper. Imagine a small tomato on the sidewalk next to a vegetable the size of a skyscraper. This is such a small Earth, and we haven't gone into outer space yet. But tomatoes and skyscrapers are not the most important thing. The Earth is very far from the Sun, 150 million kilometers away. If you went to the Sun, it would take you 176 years in a car traveling at a speed of 100 kilometers per hour. And it's non-stop. This distance is called 1 astronomical unit, or A. This is the unit of length used for objects in space. So, Neptune, the most distant main planet, is 4 billion kilometers or 30 away, but it's not the farthest object in the solar system. This title was given, as it is believed, to a dwarf planet, over the name, which was clearly thought of for a short time. Porcelain, or rather Porcelain 2018 and 37. It is located 132 or 19 billion kilometers from us, and makes a revolution around the Sun. In 700 years. Wait, but how big is our solar system? After all, it has some kind of edge. Yes, there is one. The aorta cloud is a kind of shell of space debris that can contain billions, if not trillions of objects. This is a kind of gravitational boundary between our system and the next one. Its inner edge is 5,000 and the outer one is even further away, 100,000 That is, it is more than a light year. That is, the distance that light travels in a year. And it is about 9.5 trillion kilometers. This is also difficult to realize. So let's imagine that the reducing ray changed the size of the solar system from the Sun to Neptune. Now it's not a system, but a team on a football field, 110 meters long. Then the Sun would be only 17 millimeters in diameter, like a coin, and would be on the goal line. Other planets would be located nearby, and Neptune, the size of a grain of sugar, would be 55 meters away on the opposite side. We've almost reached the edge of the field. But where would the planet Farfarot be located? But it would have been 2.5 fields away from ours. With a diameter of 402 kilometers, it would become the size of 2 strands of DNA, and it would not be visible at all. And if the outer edge of the aorta cloud is 15 trillion kilometers from the Sun, then we will have it 176 kilometers, which is equal to 600 football fields. Let's say our system is the MetLife Stadium in New Jersey. The outer edge of the aortic cloud would be further away in Philadelphia. And by the way, did you know that our solar system is one of 4,000 systems in the Milky Way galaxy? And we thought we were special. And what do we look like compared to the galaxy? Let's reduce the solar system from the Sun to Neptune to the size of a coin again. Imagine it in the palm of your hand. The Milky Way will then be the size of the entire United States. And that was just our solar system. I'm even afraid to imagine how scary it will be next. The Sun looks big, but it's one of about 400 billion stars in the galaxy. These are some of the largest objects, and against the background of some, our Sun looks like a baby in a room with NFL players. Very bright players like Sirius or the Big Dog star. The brightest star in the night sky, shining 80 trillion kilometers. The Sun has a radius of 695,000 kilometers and a diameter of 1,400,000. This is one solar radius and one solar diameter. Sirius has a solar radius of 1 and 7, 1,190,000 kilometers, and a diameter of 2,300,000, and its mass is twice as much as the so-called solar mass, an octillion tons. 27 zeros at the end. Okay, who else is on the team? But Aldebaran is a red giant, like the Sun. Although its weight is less than 1 in 7 solar masses, that is, 3 to 4 octillion tons, it is much larger, 45 times larger than the Sun. And its diameter is about 60 million kilometers. This star is easy to find in the night sky, although it is 65 light-years away, or 600 to 14 trillion kilometers away. Betelgeuse is a star with a diameter of more than 1 billion kilometers, and also 15 times more massive than the Sun. It weighs 32 octillion tons, so it's a supergiant. These stars are 8 to 12 times heavier than the Sun, and the Betelgeuse are also 700 light-years away. That's 6.5 quadrillion kilometers. The largest confirmed star is also located in our galaxy. The star of the UA shield is 1,700 times larger than the Sun, with a diameter of 2 billion kilometers. 5 billion suns would fit inside the UA shield. To realize its size, let's imagine that instead of the Sun, it is located in our system. Its photosphere, IDS the outer shell, would extend beyond the orbit of Jupiter. There's a lid in the ground, but it's still hard to understand. We use a reducing beam. Now the Sun is a basketball, and the UA of the shield will be 300 meters wide, which is close to the length of a cruise ship. But maybe it's not the biggest star. If its size is confirmed, then Stephenson 218 will put the largest objects in the universe to shame. It is estimated to have a diameter of 3 billion kilometers, a billion more than the UA shield. It is 2,150 times the size of the Sun, and it will take 9 hours to fly around Stephenson at the speed of light. For comparison, you can fly around the Sun in 15 seconds. Stephenson would fit 10 billion suns. How big is the Milky Way, considering all these stars? Its width is 100,000 light-years. If the Sun were a ping-pong ball, the Milky Way would still be 30.5 million kilometers wide. But our galaxy is not the biggest yet. We are going further than any vehicles have flown. So much so that you can say goodbye to our solar system. That's you. That little dot on Orion's swirling arm in the Milky Way galaxy. Now the Earth is so small that it is smaller than a pixel on the screen. But no matter how big it is, the Milky Way is not the only galaxy. Both he and our nearest neighbor Andromeda are the largest galaxies in the so-called local group. This is a collection of all the clouds of the nebula and galaxies, the diameter of which is 10 million light-years. Andromeda is the largest galaxy in the group, twice as wide as our 200,000 light-years with a trillion stars. It is 2.5 million light-years away from us, which is a lot. But on a dark, cloudless night, Andromeda can be seen from Earth. If it were to emit more light, it would look like this in the sky. Although light moves at a speed of about 300,000 kilometers per second because of the distance between us and Andromeda, 22 quintillion kilometers. Light reaches us in 2.5 million years. So we see it as it was millions of years ago. It's cool, right? Andromeda and the rest of the local group are located in the Virgo supercluster. This is a giant group of galaxies, and at least 100 clusters, that is, structures containing hundreds or thousands of galaxies inside. Such a cosmic roof extends over us for 110 million light-years in diameter, and its volume exceeds the volume of the Milky Way by 100 billion times. Now I feel like a speck of dust on a speck of dust that is inside another speck of dust. Inside our supercluster is the largest galaxy, ICE 1101. It's just huge. Its diameter is estimated to be from 403,000 to 550,000 light-years, and besides, its stars are approximately 12 billion years old. For comparison, the Sun is not even 5 billion years old yet. It also has 400 times more stars than the Milky Way, and in the center is one of the most massive black holes. Black holes are dense objects so heavily filled with particles and cosmic matter that even light cannot escape their attraction. They are very heavy and form at the end of the life of stars. The nearest black hole to Earth is 1,560 light-years away. Fortunately, it's far enough away, and we won't get sucked in. It has to be closer than Neptune to suck us in. But if it gets a couple thousand kilometers closer, the Earth will be destroyed and will be in a black hole in a matter of seconds. What could be worse? Well, for example, a supermassive black hole. It is formed when the holes merge and become so dense that they weigh 100,000 times the mass of the Sun. But AIC 1101 is even more unique. Its weight is approximately 40 billion solar masses, and this is a low estimate. According to some astrophysicists, the weight can be 70 or 100 billion solar masses. It has even been called an extremely massive black hole. Such holes are born big. That is, they did not grow and did not merge, but immediately became so. Fortunately, ICE 1101 is a billion light-years from Earth and does not threaten us. Although this galaxy contains an impressive black hole, the largest single black hole in the universe. That's 618 tons, 18 billion light-years away from us. Its weight is approximately 60 billion solar masses. These two black holes may be heavier than all the stars in the Milky Way, and there are, for a minute, 64 billion of them. Black holes like tons are huge. Its width is 3 and 8 trillion kilometers. 618 tons is so impressive that it refers to ultramassive black holes, the mass of which is 5 billion times the mass of the Sun. It's very difficult for me to restrain myself right now and not make a joke in the spirit of This Is Your Mother. The further we dive into space, the more difficult it becomes to realize all these dimensions and numbers. Therefore, it's time to get a reducing beam. So, if the Milky Way is the size of a penny coin, then Andromeda is a pin 60 centimeters away. The Virgo cluster in the heart of the supercluster is a 30-centimeter sandwich 15 meters away, and the AI 1101 will be 250 meters away, the size of a flash drive. But the tone of 618 will still impress. It would be 4.5 kilometers away. And although it is one object, not an entire galaxy, it would be visible and the size of a pinhead. So it's much easier for me to imagine the Virgo supercluster, and that's good. But all these objects are only getting bigger and bigger. Virgo supercluster is located in another Laniakea supercluster. Have you noticed a pattern? We are part of only one branch of the Laniakea cluster, and 100,000 other galaxies stretch over 520 million light-years. That's almost 5 sextillion kilometers. That is 21-0. The mass of Laniakea is 100,000 times greater than the weight of the Milky Way, and it is so big that it consists of 4 parts: the Hydrocentaurs, the Indian Peacock, the Southern, and the Virgo superclusters. Our nearest neighbor is Hydrocentaurus, 127 light-years away. The part called Hydra is about 10 million light-years long and 1,000 times larger than the Milky Way. How small we are! But Laniakea is not dense enough, and gravity does not hold it. But then, what's holding it all back? It turns out that an even larger collection of galaxy clusters, called the Great Tractor, is responsible for this. This is the central gravitational point of Laniakea, which stretches through the Virgo supercluster and the Hydrocentaurs for 300 million light-years. Without it, we would just be floating in space without any stars. But the problem is that the Milky Way is gradually attracted to this force. Because of this attraction, our galaxy is moving towards it at a speed of 215,000 kilometers per hour. Yes, right now we are rushing through space at a tremendous speed, and we don't even know about it. Do you know why? If the Milky Way suddenly accelerated or slowed down, we would feel it. But since the galaxy is constantly moving, we don't feel any changes. Scientists have discovered that we are rushing so fast thanks to microwave background radiation. This is the release of energy from light emanating from objects left over from the early days of the universe, which allowed us to determine that we are approaching that force. Fortunately, we will never encounter it. Unfortunately, this is because dark energy, which acts in opposition to gravity, will tear apart the tractor and our supercluster before we get close. However, this will happen only in a few billion years. But even the death of Laniakea is just a needle in a cosmic haystack. If we look further, we see an even bigger threat looming over us. The pattern continues, and Laniakea is located inside another structure of frighteningly large whale fish. This is a complex that has 60 clusters with a mass of 10 quintillion solar masses. So, how do I even say this? 40 kva. Kva. The equator is a decillion tons. 45 zeros at the end. The whale fish is a galactic filament, the largest known structure in the universe. The filaments consist of dense thin strands of dark matter, hypothetical matter that does not emit light energy, and galaxies that stretch 4 millions of light years. Since this is a complex of clusters, whale fish can be over 1 billion light years long. The Virgo cluster occupies only 0.1% of its mass. But is it the largest? Not at all. Another galactic thread, the Great Wall of Hercules, the Northern Crown, stretched 10 billion light years in length. And this is the largest single object in the universe. It is located in the Northern Hemisphere, in the constellations of the Northern Crown and Hercules, but its area is much wider. From the region of Volupus and up to the constellation Gemini. The Great Wall occupies 10.7% of the diameter of the observable universe, and its various clusters of galaxies cover more than 20 constellations and 125 degrees of the sky. It's so gigantic that it used to question the Big Bang theory of how the universe came into being. According to this theory, the universe originated from one incredibly dense hot spot that exploded, creating most of the matter and the existing force. And it is thanks to her that the cosmos is constantly expanding. It turns out that light takes 10 billion years to reach us from the Great Wall. This means that it was formed 3 and 8 billion years after the explosion, since the universe is estimated to be 13 and 8 billion years old. But according to astrophysicists, this is too small for the object to become so huge. Such a complex structure would be impossible because it completely ignores the known gravitational constraints of the early universe. Scientists are trying to figure out if they made a mistake with the age of the universe. If so, it changes everything we know about its evolution. Maybe it's just an anomaly that we haven't studied yet. In any case, we look like crumbs against the background of the Great Wall. We saw the largest object in space, and which is the farthest. Then this is Galaxy HD1, the farthest object in the universe, and one of the oldest. We see it as it was 324 million years after the Big Bang. And there may be some of the first stars in space. Physically, HD1 has since moved, and is 33 billion light years away from us. That's 318 trillion kilometers. How is it in general? But if you went there by car at a constant speed of 100 kilometers per hour, you would get there in 377 quadrillion years. Fine, who took the food? But more importantly, what's behind it? At the moment, this is the physical boundary of the observable universe. A little over 46 billion light years in all directions. And it's a sphere 93 billion light years in diameter. There are several hundred billion galaxies in the known universe and more stars than there is sand on Earth. And that's 7.5 sextillion grains of sand. Many believe that the universe, like the Earth, is spherical or flat. But it is quite possible that it is in the form of a doughnut, and some studies indicate just that. Scientists measure temperature fluctuations in the cosmic microwave background to figure out the geometry of the cosmos. Some results indicate parallel expanding lines, ideas that the universe is flat. According to others, the direction of cosmic rays changes over time, which means that it is rounded. This is due to the fact that the rays have an electric charge and behave the same way when passing through the Earth and its magnetic field. And it's spherical. Sorry, flatlanders. But there is a version that the universe is both flat and rounded. For example, if you draw parallel lines on paper and glue it at the edges, you will get a cylinder. And if you bend the two ends of the cylinder, you get the shape of a donut or a bagel. Parallel lines remain parallel, but the universe is curved and looks very appetizing. Of course, when we talk about boundaries, we mean how far we can see the universe. Why don't we see the rest? This is because light could not reach the Earth from a greater distance, since the time it takes to travel from such distant objects is greater than the estimated age of the universe. As the cosmos gets older, more and more light will reach the Earth. But, unfortunately, the light from many objects will never reach us. Therefore, we don't know much about infinity beyond that boundary. Scientists estimate that the invisible universe is at least 250 times larger, and at least 7 trillion light-years wider than the visible one. But let's stop at what we see and try to reduce it. Let's turn the Milky Way into a millimeter-sized grain of sand. What will the rest of the universe be like in comparison with it? So, Virgo's supercluster would be the size of a guitar, and Laniakea would be like a canoe. The whale-fish complex would be somewhere like a small bus, but the Great Wall would be higher than the Statue of Liberty, from the foot of the pedestal to the torch. Finally, the observable universe. How big do you think it will be? Maybe the size of a standard Olympic swimming pool or a house. Not again. Its diameter would be greater than the height of the Burj Khalifa in Dubai, the tallest building in the world. Here is such a journey through the universe. It's hard to realize how gigantic everything is, right? When you look at the stars, you will no longer consider them small. In fact, I can't figure out whether this information calmed me down or inspired existential horror. How small do you feel? Share your impressions in the comments, and thank you for watching.